Vulnerability scanners give you findings, but findings are not tickets. A scanner report might say CVE found severity high, asset affected. That is not enough for an engineer to know what to fix, why it matters, who owns it when it is due, or what proof closes it. So in this video, I am building the workflow I wish every vulnerability management team had: an AI agent that turns scanner findings into remediation ticket drafts, not auto-publish chaos, draft, enrich, prioritize, route for approval, then create the ticket. Here is the problem with most vulnerability workflows. Security exports a report from a scanner. Engineering gets a giant list. Some findings are duplicates. Some assets are not production. Some vulnerabilities are technically high, but not reachable. Some are medium, but sit on an internet-facing system with sensitive data. And the ticket often says something like remediate CV 2024, whatever. That is not a remediation workflow. That is a transfer of confusion. If the ticket is vague, it gets ignored. If the severity feels arbitrary, it gets debated. If ownership is unclear, it stalls. If the closure evidence is not defined, nobody knows when the work is done. The goal is not just to move a finding into another tool. The goal is to create a ticket an engineer can actually act on. The agent starts with messy scanner output. First, it normalizes the fields: asset name, IP address, CVE, package, scanner severity, first seen date, last seen date, exploitability signals, business owner, environment, internet exposure. Second, it deduplicates. If Nessus, Quailes, and another scanner all found the same issue on the same asset, the engineer should not get 3 separate tickets. One real issue should become one clean remediation draft. Third, the agent enriches the finding. Is this system production? Is it internet facing? Does it support a critical business process? Is there known exploitation? Is there a compensating control? This is where the ticket becomes useful. The agent is not just repeating scanner severity. It is adding the context that explains why the work matters. A bad ticket says high vulnerability found. Patch OpenSSL. A useful ticket says OpenSSL on the production API server is missing a security update. This system is internet facing and supports customer authentication. Update OpenSSL to the approved patched version. Restart the affected service during the maintenance window, and attach scanner evidence showing the CVE is no longer detected. That is the difference. The first one creates noise, the second one creates action. Here are the fields I would have the agent generate: title, affected asset, business owner, environment, risk summary, recommended fix, evidence required, due date, priority reason, related duplicate findings, approval status, and the most important field, human reviewer, because I do not want this agent automatically creating tickets for every scanner result. That is how you create a different kind of noise. The better workflow is draft first. The agent prepares the remediation ticket. A vulnerability analyst reviews it. They can approve, edit, merge, defer, or reject it. Only after approval does the ticket get created in Jira, ServiceNow, Linear, or whatever system the team uses. This keeps the speed benefit of automation without removing accountability. This is where AI agents become useful in cybersecurity, not as magic decision makers. As workflow operators, they take messy inputs, apply consistent logic, produce structured outputs, and stop at the point where human judgment matters. For a vulnerability analyst, this is also a strong portfolio project. You can show that you understand scanner, output, risk context, remediation workflows, ticket quality, and approval controls. That is more valuable than just saying you know vulnerability management. The point is simple. A vulnerability finding is not the deliverable. A clear, owned, evidence-based remediation ticket is the deliverable. And an AI agent can help create those tickets faster as long as you design the approval gate correctly. If you are finding this content useful, please subscribe, like, and comment.